Cool. Good morning. Thank you for all attending my short speech, or rambling you could say, this morning about technologies that Powerstar offer. I'm James. I'm one of the principal engineers at Powerstar. I look after the product development and the roadmap of the technologies that we deliver to market. So we're going to touch briefly on Powerstar, what we do, who we are, where we come from. And then we're going to talk about the 3 pillars of technology that Powerstar currently offer, and we will dive ever so slightly into the roadmap looking for FY26, and then financial year going into 27 as well. So, Powerstar. We are part of a business called D20. So as you can see, we are number 1 in the list of businesses, if anyone asks me. But we form a group of businesses. The purpose of us is to enable the energy transition to cleaner energy. Now, not just electrification, but we can be looking at alternative fuel sources, such as hydrogen. We also then look at integrating lossless valve systems through our partner company, Score Group, and then looking at hydrogen electrolyzers through Hydrosun, and then Kelton and Nexos bring up the EPC element of the business. Powerstar, we are electrification. That is the purpose of Powerstar, that enablement of electrification. So when I speak to people about what do, we don't do electrified steam boilers. That is an electrification company, but we enable that infrastructure. We enable people to have access to electrified solutions and greener energy. So, specifically within the food industry, but this is pretty consistent throughout most of the manufacturing industry that we see in the UK and also worldwide. But the 3 main challenges are the rising energy cost. We've all seen it, not just in business, but at home. I know I get an Octopus energy bill every month, and I tense up when I see that bill. The drive for decarbonisation, ESG policies coming in, tighter legislation, tighter regulations from the businesses, from the government to the business to achieve net zero. And then the challenges to electrification. So the grid constraints that we all keep running into over and over and again. People putting solar on, can't get an export agreement. Businesses needing to electrify, like say, steam plants or heating elements, and not having the import agreement or the infrastructure either on the private network or from the DNO to allow that transition to non-fossil fuel sourced energy or power, however that way may be. So specifically with the energy industry, and sort of a case study that I'm going to be using is one of the customers that we deliver our solutions into are looking at replacing their steam boilers with their gas steam boilers with electric steam boilers. So this was one of the 3 big challenges that we were going to find. So the 3 pillars, this is what I'll go on over and over and over again. Ultra low loss transformers. So 90% of the transformers that are in application today are CRGO, cold rolled grain oriented transformers. So the steel laminates or the metallic laminates that are inside the transformer are made of this CRGO material. Eddy currents, people may have heard of, or losses in transformers through circulating currents of the ferrous core account to about 4% of the loss of the transformer in some older transformers. So by replacing them with amorphous core transformers means that you get 99.7% efficient transformers, so your losses are really, really, really reduced. This is a fantastic option for people who have resistive power loads or power loads that aren't suitable for any other type of power quality improvements. Voltage optimization. So a lot of people scrunch their face up at times when they hear about voltage optimization. It's been sold as snake oil for many, many, many years, but we're here to break that trend. So 5 years ago, 10 years ago, voltage optimization probably would have cured world hunger, if you ask one of the salesmen, and it would have got you 10 to 15% energy savings. Quite frankly, this day and age, that doesn't happen. So you are looking between 5 and 8% energy savings in the right application. So people like data centers get no benefit from it. People with resistive heat loads get absolutely no benefit from voltage optimization. However, heavy industry, inductive loads, plant equipment, do get good energy savings. Where you've got a mixed load on site, specifically like we find in the food and drink industry, with a lot of pumps for motors, a lot of motors for pumps and mixing, they come out really, really well. And then battery energy storage system. So we're going to get onto that one ever so slightly. But this is a little bit of a different technology than the transformers and the voltage optimization. They kind of fix in two different problems. But as a solution of all three of these packages, you improve your energy resilience, you break down the barriers from the national grid, and you also become greater energy efficiency. So you're hitting all your ESG goals. It really is sort of that complete solution, and that's what we're going to bang on about a lot, about solutions. So, just talking on VO, we're going to do a little bit about how it works. This talk is predominantly VO focused, but we are going to spend some time on BESS and transformers as well, as quick as we can. So, like we mentioned, 5 to 8% of your energy bills. So that's a reduction in kilowatt hours. Now, it's not the device itself saving you the energy. What it is, it's the device regulating the voltage, making sure that it's at its most efficient point for the equipment on site to work most efficiently. So the energy saving actually comes from the devices, the drives, the motors, working within their most efficient parameters, not the device itself. It's the impact of what that does. If you asked anyone years ago, they said, no, it's the voltage optimization device that saves you the energy. It's not. It's the efficiency that it brings for the equipment. By making this equipment run more efficiently, we then start making it use less energy, less heat, less wear and tear. So as we know, bearings, motors, oils, the warmer they get, the least lifespan the devices have. By reducing this and making it more efficient, the heat loss goes down, the bearings run longer, switch mode power supplies work better as well, so the drives and the inverters also see a benefit from this as well. Carbon emissions is also, it comes hand in hand with the energy saving. So if you're on a green tariff already, you don't get any carbon savings. But if you're still importing energy on non-green tariffs or in non-green periods, then you'll get the carbon savings via the reduction in kilowatt hours. So how does it work? We've got a factory, we've got a processing line here. So we've got no voltage optimization on this factory, and we've got outdated transformers that are on site. So typically doing the 11 kV to 433, so 433 volts. Equipment in the UK that is CE marked has been designed to the IEC standard and designed to run at 400 volts. That is what it should be. So when people go to you and say, oh, I've got 3 pin, I've got 240 volts, it shouldn't be, it should be 220. That's what the standard says. So by having this over voltage and this oversupply of voltage, that motor's getting quite hot, running not particularly efficiently, burning excess energy. So by going with that VO, reducing that voltage from that 248 volt average that we see allows the device again to run more efficiently. So 220 volts, remember that number, because that's quite a key number that we target. So this is a VO unit. We supply the 248 into it, so we divert your incoming tails from your transformer or out of your switchgear into the voltage optimization device. Now, this device isn't a box of electronics. It is half, but not all of it. It's not as complicated as a lot of people make this device out to be. It's the control of it that gets hard. So, inside a VO device, and this is every VO device out there, this isn't just Powerstar, this is every VO device that's out there, is an auto transformer. So people think, oh, we can just tap transformers down, we achieve the same effect. Yes. Not to the resolution that we have here, not to the control that we have in our devices, but we have an active compensation device inside there. So the difference between just a tapping down of the transformer and the voltage optimization device is that we have control, because we can tap up and down. So as your grid voltage fluctuates, we can regulate that voltage going up and down rather than just being fixed. If it was fixed and your grid voltage comes down, your output voltage of the transformer will go down, and you could potentially at the risk of running brownouts and other such events and causing disruption to your production facility. So supply voltage comes in. We use double-backed thyristors. So I've been able to sort of simple them or simplify these for the power for the presentation and showing switches, closing the taps on the different transformer. But we basically are reducing the voltage, and between each of these taps is a 2.5 volt reduction. So as the energy and the voltage is being monitored, we are regulating and closing these taps within a 2.5 volt band, regulating that voltage at 20 or 220 volts. And there we are. So just by using transformer technology that has been around for numbers and numbers of years, and pairing it up with some intelligent electronics and some intelligent control systems, we are able to regulate that voltage nicely. And then the equipment then starts running more efficiently, less heat. You start getting a longer lifetime out of the devices as well, saving you energy as well. And that's running at 220 volts. Now, we try and target 220 volts at the point of use. So actually what we regulate the voltage to at your incomer is 224, just to take into consideration volt drop. What is crucial to mention is that, like I say, this is application specific. This technology isn't for everybody. There's going to be some people where it works really, really well. There's going to be some places where it doesn't work so well. So every single time we put a VO device in there, we will do a full intrusive site survey. So we're looking at your switchgear. What we also will be doing is a full power quality analysis. VO, like I say, isn't the fix for a lot of the applications, and isn't the most effective solution. Harmonics is one of the larger energy wasters, you could say. The fifth harmonic is the killer. Everybody hates the fifth harmonic. It's the one that fights back. So that also is something that we take into consideration, saying, is VO suitable, or is VO and harmonic filtration suitable? A lot of questions that I get as well is, oh, well, I've already got power factor correction, I don't need VO. Two different problems, fixing two different things, they work hand in hand. So one's changing reactive power or making reactive power active power and reducing it on an energy charge, whereas this one is an energy saving device. So we are quite solution orientated how we deliver the VO technology. So I've not got any fancy animations for this. I'm trying to get there, but it's a little bit hard to demonstrate how electrons flow in eddy currents through amorphous core and through CRGO and not through amorphous core, but we'll get there. But like I say, this is one of the leading causes of wasted energy in production facilities, is outdated transformers that are on site. So again, these are what most people know as the 11 kV distribution transformers, the 11 kV to 433 or 415, and these are what we look to replace. Now, Powerstar offer a technology that we call the HV Max. This is a VO system within an 11 kV transformer. So rather than having the wasted energy at the transformer and then trying to get savings after the transformer, we bring that all together, and we're able to deliver a solution that can provide better savings. But again, what's right for the application, what's right for the site. So this is the one, again, no animations just yet, but we're getting there. Battery energy storage systems. So this fixes more problems than people can imagine. Now, people go to me, oh, well, it's a battery. What does it do? Stores energy. We can discharge energy. We can charge from the grid. So people see these going alongside renewables. So I've got a wind turbine, or I've got a PV array that's on site. We need a battery, and that's all it's really good for. It's actually, this thing can do way more than just renewable firming. So we've got the overcoming grid constraints, again, using a battery to parallel feed. So the peak power when some of the drives or the devices that are being run, using a battery to boost that power supply for an amount of hours whilst that machine is running or starting up is something that the battery can do. So rather than paying National Grid or your local DNO an obscene amount of money to put a bigger cable in the road or upgrade the downstream supply point, by putting a battery in, allows you to be able to access the technologies that is needed to do the to enable your decarbonisation. you can pair this up as well. So I like to think about a battery as having layers. So you could put renewables and overcome grid constraints in there as well. So it's not just there's a battery for this, there's a battery for that. Again, like I sort of said, the battery stores energy, charges and discharges through conversion systems. It can do lots of different things. It's just how you control the system. Now, the one at the bottom is the uninterruptible power supply. So this is something that gets really, really, really fun and interesting, is requested so often. We can back up the whole entire site load with 20 milliseconds. So we have a switching device that would take up the site load in an event. So whether that's a grid outage, whether that's a frequency response issue, whether that's power quality, the UPS system is there that within 20 milliseconds, the device would switch over to load onto the BESS. This is very, very, very popular for us in pharmaceutical. So we do a lot of work for GSK, Haleon, AbbVie, people like that, where data, that's the big one that people say to us, data is more important than the product, and that traceability. And that's the same here in the food and beverage industry, that people want to know what's happening with their product, what's the data. But then also process control. So we do a lot, believe it or not, cement works. If they have a power outage on site, it takes them 12 hours to clean out all the chutes and all the mixers and get it back going. So in loss of downtime and loss of earnings, the UPS system comes into play and keeps that site alive, and they have no interruption to their power. The NHS is a real key and real big customer for us. So we have our battery systems, our UPS battery systems. We're the only people that have the accreditation to put UPS systems in hospitals, specifically in care-based applications. So we have these systems sat around trauma centres, we have these systems sat around day surgeries. If the grid goes, no one wants anyone to not wake up, so the UPS then kicks in, and that's what we specialise in. So the UPS is our real building block of technology. It's one of our real big USPs. But then being able to allow the access to the same technologies for different applications is something that we're really keen on doing. So these again are just some VO applications that we have here, and as you can see, we've got a few different key customers and a few different applications that you can see here. So Quorn, one of our real big customers, being able to deliver the HV Max technology into their manufacturing site. In the energy saved was 365,000 tonnes, not just 365 tonnes, 365,000 tonnes of CO2 over the year. Wienerberger is a brick manufacturer. They have some real intensive process equipment that was using a lot of energy. So this is where we start talking about a mixed load application. The heating elements that was the breaking of the bricks didn't really have much effect on that. However, what it did do is the mixture of equipment on site, the motors, the various different pumping systems, that then generated. So we averaged throughout the year an 8% energy saving just on one of their sites. And then the Vernick Group, modular solutions, so the modular local equipment rooms, the modular offices that you sort of get on building sites typically come from these guys. And they have a slightly better energy saving through our LV Max technology on that particular site, and that was 9.2% of their energy was saved through a year. And that's done through a validated M&V process that we do either annually or ongoing to make sure that we are projecting the savings correctly. So that's a little bit about the technologies. There's a lot to sort of take in, and I know I can't talk for hours about how the technologies work, even though I'd love to. We are on the stand just behind us there, stand 54 on the corner. So if anybody does want to come and talk to us about anything specific about batteries, VO, transformers, do come and let me know. I'm happy to answer any sort of questions about does the technology work for me? How does it fit my application? Or if it's just I don't think VO works and want to have a conversation about it, I'm more than happy to have that conversation and try and win you around about how it works and demonstrate it. So thank you all for listening to me ramble for 20 minutes. I appreciate it, and I'm sure we'll speak soon.